Free response question number 3 on Unit 3 practice test. Let f of theta equal sine squared theta and g of theta equals sine theta plus 1 minus sine squared theta. Write f of theta as a cosine function using a Pythagorean identity. All right, so sine squared theta is connected to the Pythagorean theorem identity, sine squared theta plus cos squared theta equals 1. So that comes from a squared plus b squared equals c squared, where you would be my a squared, I guess, you would be my b squared, you would be my c squared. And this technically is saying y squared, because you know sine is y, plus x squared for the same thing, cos is x, plus equals 1 squared, and then you get that. Just thought I'd share that with you. Now what we would do is we would subtract cosine squared theta from both sides. Subtract cosine squared theta from both sides, cross u out, and that leaves us with sine squared theta equals 1 minus cos squared theta. So we can rewrite out f of theta as 1 minus cos squared theta. And that's how you do A. All right? All right. Find when f of theta is 1 on the interval 0 to pi. All right, well, f of theta is sine squared theta, so sine squared theta equals 1. Let's get rid of the squared by square rooting both sides, and don't forget that when you square root both sides, you add the plus or minus, and that leaves you with sine theta equals positive or negative 1. So let's set up two separate equations. Sine theta equals positive 1, sine theta equals negative 1. Why did I leave all that space? Well, in order to get theta all by itself, we got to inverse sine both sides, baby. Alright, inverse sine both sides. I'll do that over here, but let's just focus on one at a time. Alright, so theta is going to equal the inverse sine of 1. Now, when is sine 1? Well, if we think of a regular sine function, it starts at 0, 0, peaks out, bottoms out, resets. Okay, that peaking out happens at 1, and that happens at pi over 2. So the inverse sine of 1 is going to be pi over 2. Now we do the same exact thing over here, where we inverse sine both sides, cross u out, theta is going to equal the inverse sine of negative 1. And we do the same thing that we did over here. When does it bottom out at negative 1? Well, it bottoms out at negative 1 at 3 pi over 2. So this theta is going to be 3 pi over 2. So my answers for B are going to be theta equals pi over 2 and 3 pi over 2. So that's part B. Now to do part C, it's asking us to find f of theta equals g of theta on the same interval. That means setting these two guys equal to each other. So I have got sine squared theta is going to equal sine theta plus 1 minus sine squared theta. So what I want to do is I want to move everything to one side, and let's move everything to the left by subtracting u, and adding u. Okay, I'm going to be lazy so I can save a little bit of space. I have a feeling I'm going to need it for this one right here. If we add sine squared theta to both sides and add sine squared theta to sine squared theta, that leaves us with 2 sine squared theta. Then we have on the left now minus sine theta minus 1 equals 0. So in my mind, okay, a little thought bubble that I'll bring the thought bubble up here. So pretend this is my head over here with a thought bubble. Is I don't like all that sine stuff. So why don't I pretend that that looks like 2x squared minus x minus 1 and then factor that out. Well, that would be a really good idea. And if you were to factor that guy out, that guy would factor out to 2x regular x. If we make that minus 1 and plus 1, I think that would work. 2x squared minus 2x plus 1x minus 1, that'll do the job. So taking this guy, and instead of x using sine theta, this factors out to 2 sine theta plus 1 times sine theta minus 1 equals 0. All right, so where I have this space over here, okay, where I have this space over here, and let me get rid of that. Let's use all the space that I can. I'm going to set up my two separate equations. So I have 2 sine theta plus 1 equals 0. And then I have sine theta minus 1 equals 0. Minus 1, 2 sine theta equals negative 1. Divide 2, sine theta equals negative 1/2. Inverse sine both sides, like so. And now my job is to make a unit circle over here and try to find out what happens when the y value is negative 1/2. Now, if a y value is negative 1/2, that's going to happen in quadrant 3 and quadrant 4. Negative 1/2 is going to be, and again, this is the y value. You have your dots here and your dots here. Negative 1/2 is going to be, for a y value, the dot closest to the x-axis, so these two guys. That gives me 7 pi over 6 and 11 pi over 6. So theta in this case is going to be 7 pi over 6 and 11 pi over 6. Now we got to do this guy. Let's add 1 to both sides, cross you out. Sine theta equals 1. Inverse sine both sides, inverse sine both sides, cross you out. And theta equals the inverse sine of 1, which I already know what happens is pi over 2. So this is going to be theta equals pi over 2, which is here. So writing this all out in one final problem, we have theta equals, in order, pi over 2, 7 pi over 6, 11 pi over 6. And that, ladies and gentlemen, is how you do it.